Hello everyone. In this video, we shall see how to solve the questions basing on Newton's laws, and in particular Newton's second law, F is equal to ma. So F net is equal to ma. Based on this, we will be solving questions. This particular case, there is a pulley and the two masses hanging in the support of a string passing over the pulley, and we assume the pulley is not offering any friction. And Then I have taken mass M1 as 10 kg and mass M2 as 7 kg. We can actually change them. Now let us see how to solve the question like the unknown force. If there is any unknown force or unknown mass, it can be found using the Newton's second law. So before that, let us first see what are all the steps to we follow for solving the questions basing on the Newton's second law. The first ever step is in solving F is equal to ma problem, first we will make a diagram and then we will choose the positive direction and in which the body changes or moves is taken as positive direction. So in this particular diagram is already there and you can just see like where the body moves. And here, obviously, the 10 kg is greater than 7 kg. So red block move downward. So this is for this is taken as positive, and for M2, it just tends to move upward. So this direction is taken positive. This is the step one. Step two is going to be drawing free body diagram. What do you mean by free body diagram? The free body diagram is the diagram that shows all the forces acting on that particular body. So when you are looking at M1, we draw only the forces acting on M1 and M2, etc. After drawing the free body diagram, we will identify the net force acting on that particular body. For example, M2 is going up. What are all the forces acting on the body? What is the net force? Once you find the net force using the diagram, and then we apply Newton's second law, which is F net is equal to ma. And finally, fifth one, we will solve for the unknown. These are the 5 steps. The first step is making a diagram and then deciding what is positive direction. Second, free body diagram. Third, finding net force acting on the body. Fourth, equating net force is equal to mass times acceleration. And fifth, solve for the unknown. These are the 5 steps. Now let us find out like how do we solve this question. So we can run the simulation and find out. But before I run the simulation, we will see like how do we follow the 4 steps. The first step is over. Now the second step is free body diagram. Now let us first draw the free body diagram for mass M1, free body diagram of mass M1. So let's just put a dot for the mass M1. Let me take red because it is a red block. All right. This is mass M1. And what are the forces acting on the body? For any body, whether it is moving up or down or horizontally, always gravity is always there, which is m1g, because I'm talking about m1 mass, so m1g. And as it is supported by the tension, the rope with the string, in which the tension is acting in the opposite direction to make it stiff. So tension is acting in this direction. Okay. And there is only one rope. There are no other tension because as long as the rope is not changed, so tension remains only one, the single tension. If you look at, we also have to indicate in the free body diagram, which is greater force. So as this body slides down, the weight of the first body would be more or greater than the tension. So let me just draw with the longer arrow mark, which indicates that M1 is more. Correct? Now, once you draw the free body diagram, you will apply the net force. Before that, let me also draw the free body diagram for the mass 2. Free body diagram of mass 2. Just put a dot again for mass 2, which is this, the blue color block. So this is going to be M2. And again, first ever force is the gravitational force. Now I'm talking about M2, so M2G will be the weight of the body or gravitational force acting downward. And the tension, as the body is accelerating upward, tension would be more. So I'm drawing a little longer line. Okay, so tension is upward. Now the second step is going to be, the third step is going to be F net. What is F net? What is the net force acting on the body? And in these two bodies, if you observe, this is going to be greater than this for mass M1 because it just slides down, right? So net force is going to be M1G and minus T is the net force. Okay. The reason I wrote minus T because this is opposite to the direction of the gravitational force. And in the same way for the second body, let us also write this as F net is equal to MA, fourth step. So this F net is equal to MA. So I'm writing M1G minus T is equal to MA, right? Let me take this as equation 1. Now go to free body diagram 2, M for mass 2. That means this blue color block. Now write the net force as this body is undergo tension in the upward direction and the gravitational force downward, tension is greater because it is being pulled. So T net force is going to be T tension minus M2G because it is acting downward, right? Tension is acting upward and weight is acting downward. It is equal to net force. And again, we know net force is equal to mass times acceleration. T minus M2G is equal to M2A. Here I forgot M1. M1A. This is M2A. This is equation 2. Now, are we done with the 3 steps, 4 steps? Just check it out. First, we drew the diagram. Second, free body diagram. Third, we identified net force. Fourth, net force is equated to mass gain. Then we will have to solve the last step. So how do we solve this? We know that the tension is same. So you can write from equation 1 tension. Just by transposing equations, you can write M1G minus M1A is going to be tension. And then the tension acting on the second T is equal to M2A. When you transpose this, you will get plus M2G. Now we will equate these two because these two are same. This is equation 2. Now when we equate these two, M1G minus M1A is equal to M2A plus M2G. Now let us transpose M1's one side and M2's one side. So when I bring M to this side, I get M1G minus M2G is equal to M2A plus M1A. Correct? Now we can solve this. What is mass 1? 10 kg, right? So let me just write 10 here. 10G minus mass 2 is 7G is equal to M2 is 7A and M1 is going to be 10A. Now solve this. 7G is subtracted from 10G, so 3G. And this is going to be 17A. So A is equal to what? 3G by 17. So 3 into 9.8 by 17. When you substitute this 3 into 9.8 by 17, use calculator, you would get 1.73 meter per second squared. This is acceleration. So we got acceleration. With this acceleration, M2 moves upward direction and M1 moves downward direction. So we solve for acceleration. So let us remember 1.73 as acceleration. Now A is equal to 1.73 meter per second squared. Now, when you substitute this in any one of the equations, you would get the tension. So as I erase this off, let me just take the 10 kg mass because solving something that has 10 is easy, right? So I'm just drawing once again. This is M1G, this is tension T, and this is going in the downward direction as I release. So what is this equation going to be? M1G minus T is equal to M1A. Now I know A, correct? M1 is 10. 10 into 9.8 minus T is equal to 10 times 1.73. So when I solve this, this becomes 98 minus this becomes 17.3, and it is going to be 80.7 newtons. So tension is 80.7 newtons. All right. Now let us just check what is here. First, let me click on the free body diagram. Is this correct? Tension acting upward, M2G downward, tension acting upward, M1G is downward. Let us show the numerical values. Now look at the acceleration, 1.73, 1.73, tension 80.7, 80.71, 80.7. So that means this is proved to be correct. Let me run this simulation. Look at this. By the time it reached down, the tension developed in the string is 80.71. The acceleration produced in the entire system is 1.73. We also can solve velocity and time using equations of motion. So you just let us imagine this is the initial position of this red color block and it has traveled 2.18 meters. It is shown here. So you can just substitute equations of motion to find out velocity. Velocity is here. How much is this velocity? Initially, it is at rest, correct? Now the displacement from here to here is going to be 2.818. I'm ignoring negative sign here. So now we have VUS. So I can use the third equation, which is V square is equal to U square plus 2AS. With the help of this formula, you can just say V is equal to under root U square plus 2AS. And then this is going to be 0 plus 2 times acceleration is 1.73 and times the displacement, which is given 2.18. So when you solve this, you will get like 7.5774. When you solve this, you will get 2.75 meter per second. Meter per second. Look at this. Velocity is 2.74. Again, one more thing is how long does it take to fall down? That also can be the question in your exam. How long does it take? Time is equal to how much? Again, use any of the equations which has time. V is equal to U plus AT you can use, right? Because we have V. So 2.75 and it started from rest 0 and acceleration of the system is 1.73 and time. So time is going to be 2.75 over 1.73. When you use calculator, it would be 1.59 seconds. See, 1.59 seconds. So all these are answered. Acceleration, tension, velocity by the time the block comes to the ground or reaches the ground, the time taken for the block to reach the ground, 1.59 seconds. Okay, these are the 4 steps that we follow for solving questions using Newton's second law. Thank you for watching.